Heat is a form of kinetic energy that is transferred by particles bashing into each other. So let's say I have cold, slow-moving particles on the left and some hot, excited particles zooming around on the right. Heat transfer occurs when more excited particles slam into less excited particles and transfer some of their energy. This is happening all around us all the time, and it always moves from hot to cold. And there are three different ways that this heat transfer can occur: conduction, convection, and radiation. In this video, we're going to talk about conduction. Conduction is the direct transfer of heat from one object to another. It occurs from the movement of particles. You could also think of that as molecular vibrations. In conduction, heat is transferred from one end of an object to another, as determined by thermal variation. Because remember, heat always flows from hot to cold. If there's no temperature difference, there's no heat transfer. As heat is applied to one end of an object, the molecules increase in vibration, and heat is transferred throughout the object. The key word to remember in conduction is direct. There are some essential things to remember about conduction. 1. Conduction occurs as a result of temperature difference between two solids. And 2, those solids must be in direct contact with each other. And 3, a medium, usually the molecules or atoms in a solid, are required for the transfer of heat to occur. Conduction happens through two different types of motion. There's a lattice vibration, meaning that the atoms or molecules closest to each other are moving and causing collisions. Materials that are non-conductive, like rubber, transfer only via this lattice wave vibration. There's also electron motion, where the electron peels off and zooms around, causing additional collisions. You gotta love free electrons, because they just go where they feel like going and ignore that stagnant lattice structure of most solids. You can find them in most metals. Good conductors like copper or steel transfer heat via both types of movement. From an infrared perspective, conductive heat transfer creates a beautiful thermal gradient. No matter what palette you happen to be using, you'll see changing rings of color that expand away from the source of the heat. So let's consider a motor for a few minutes. When inspecting motors, one of the first things I do is check the housing for unusual thermal patterns. What I want to see is that lovely gradient that starts in the center of the housing and fades and rings outward, just like this picture here. Now, granted, I've used my palette to exaggerate this gradient, but I wanted to be sure that you could see it. Note that we have the hottest part in the center where we want it to be, and then the color in the palette morphs gradually to cooler temperatures. So what's happening here? Well, as the winding moves around, it heats the metal of the housing, and then the metal conducts the heat outward to colder areas. So what can cooking hot dogs teach us about conduction? The metal of the grill heats up from contact with the propane flame below it. Because of its conductivity, the metal grill plate does its best to come to thermal equilibrium with the flame, so that it is uniform and steady. So take a look at this beautiful gradient. You can clearly see the hotter part of the grill plate. It's right there. Moving out from the hottest point, we can see rings of color. And that is a clear thermal sign of conductive heat transfer. If we add some hot dogs, we introduce a new element to the party. The hot dog has direct contact with the grill plate. Both objects now try to reach thermal equilibrium. Because the hot dog is colder, the heat moves up and through the hot dog. So now you see that similar gradient pattern working its way up the side of the dog. Shazam, conduction. So let's go to the videotape and watch the process in infrared. And I'm going to speed it up the video a little bit to help you understand and see the difference and see the changes in the gradient. Thanks for watching. Don't forget to like and subscribe, and if you want to see something in infrared, let me know in the comments. Thanks.